Alright, so now we're going to talk about factors and factorization. So for example, any numbers, including prime numbers, has factors. So they're numbers that when you multiply them together, you get that number. So for example, the number 30, right? The first factor we can think about is that you can multiply a number times 1, right? Any number by itself times 1. So 1 is a factor, and we know that 30 is a factor, right? But what other numbers can we multiply or can we use to get 30? So let's try 2. Alright? 2, so we should divide that. 30 divided by 2. So 2 goes into 3 once, minus 2. So bring it to 10. And then 2 goes into 10, 15. Alright, so we have 2 and 15. Are there any other factors? Well, let's see here. Let's keep going. So what about 3? Let's try 3. Does 3 go into 30? So 3 goes in 3 once. 3 minus 3, 0. Okay, 3 times 0 is 10, or 0. So goes 0. So you know that 10 goes into 10 times 3 is 30. Are there any others? So let's try 4. Will 4 go into it? No, 4 does not go into it, right? Because 4 times 7 is 28, but 4 times 8 is 32. How about 5? Let's try 5. 5 into 30. Let's see, yes. Goes 6 times, isn't it? So we have 5 and 6. And then are there any others? 7, no. 8, no. 9, no. 10, we already have. So these are the factors of 30. 1, 30, 2, 15, 3, 10, 5, and 6. Okay, let's try one more. Let's try 28. So pause the video, try it on your own. Okay, so let's do the obvious one. So 28 is a factor, right? Obviously the number itself, and then 1 is a factor. What about 2? Let's keep going up. So is 2 a factor? So let's try 28, divide that by 2. Okay, so 2 goes in 2 once, 0, bring down to 8, and then let's see, 2 goes into 8, 4, yes. So we have 2 and 14. Are there any other factors? Does 3 go into 28? No, it doesn't. Does 4 go into 28? Yes, it does. Because 4 times 7 is 28. Okay, are there any others? 4, 7. I think we pretty much got them all. So factors of 28 are 1, 2, 4, 7, 14, and 28. Let's try it. Now let's keep moving on. You know, listing factors like this is okay, but it's kind of tedious. So there's a thing what we call a factoring tree, and this is what I mean. Okay. So for example, let's take the number 40. Okay, the number 40. Okay. What you want to do is you want to find 2 factors that goes into 40. So let's try this. What are 2 what can be 2 factors that go to 40? Okay, let's try 4 and 10. okay? Because 4 times 10 is 40, okay? Now, when you do a factoring tree, what you want to do is you want to keep reducing each factor to its lowest prime power. So you want to reduce it to like prime numbers like 2, 3, 5, 7, what else? 11, right? So you want to keep reducing these factors into these smaller prime numbers. For example, 4, you can reduce this into what? 2 times 2, right? So right here we've reduced it down to prime numbers of 2. Okay, so when you reduce it down to prime numbers, I want you to circle them. It's a good way of remembering what the prime numbers are. Now let's go to 10. Now what are the factors that go into 10? Well, it'll be 5 and 2, right? So is 5 a prime number? Yes, it is. Is 2 a prime number? Yes, it is. So the final answer is you want to put everything into prime power form. So in other words, you want to take the prime numbers, for example, like 2, and you want to use exponents. So how many 2's are there? There's 1, 2, 3 of them. Because there's 3 of them, there's 2 to the 3rd power. That's what it means. 2 times 2 times 2. And then we have, what do we have left over? We have 5. So the final answer is going to be 2 to the 3rd power times 5. This is actually a much more efficient way than trying to like divide everything. It doesn't take as long. So let's try a couple others. Let's try 48. Pause the video and do it on your own. Okay, so what are 2 numbers that go into 48? If you remember your multiplication tables. Well, let's try 6 and 8, right? 6 times 8 is 48. So to do these factorization, like, you know, trees and stuff, you have to be really good at your times table, right? So what can we reduce 6 down to? What factors can we bring out of 6? Well, how about 2 times 3, right? 2 times 3 is 6. And 8, we'll see, 4 times 2 is 8, right? Can we keep reducing? Well, let's first circle the prime numbers. We have 2 here, we have 3 here, we have a 2 here, but this is not a prime number, so we keep reducing, right? So 4 is also 2 times 2, which these are also prime numbers, right? So the final answer is going to be 2 to the, so let's count how many 2's we have. We have 1, 2, 3, 4. So we have 2 to the 4 power times, and then we have 3, right? Times 3. So the final answer is going to be 2 to the 4th power, 2 to the 4th power times 3. Alright, let's try one more. How about 72? Alright. Okay, so can we reduce 72 into 2 factors? Yes, we can. And what those 2 factors might be? Let's try 8 and 9, because 8 times 9 is 72. Okay, so are these in prime form? No, they're not. So let's keep reducing. So 8 is 4 times 2, and then keep reducing that, and then 4, it becomes 2 times 2. So let's circle the prime numbers, right? 2, 2, and 2. How about 9? We can reduce 9 down to 3 times 3, right? And these are prime numbers, right? So the final answer here is going to be 2 to the, how many 2's are there? 1, 2, 3. 2 to the 3rd power times, now how many 3's do we have? We have 1, 2. 2 of them, so 3 to the 2nd power. So this would be the final answer, 2 to the 3rd power 3 to the second power.